The determination of consistency is for you to check whether the system of linear equations is consistent or inconsistent. If it is consistent, then what kind of solution would it have? One solution or infinitely many solutions? So let's say you have been given an augmented matrix form. So the first step you need to do is you reduce it into row echelon form, because we don't want the entry in front of the leading one here to disturb with your estimation and predictions. So in this case, the unknown is A, and we don't know what would be the values of A. So after you reduce into row echelon form, you need to do some inspection. So this inspection is important because you can use it to predict what kind of solution you will have. Apparently we have three columns here corresponding to the three unknowns. So let's call it as X, Y, and Z here. So the first question is, we want to know what values of this unknown A such that the system has no solutions. And remember from the lessons, in order to have a no solution, you need to look at the illogical expression such that the coefficient here corresponding to the unknowns are all zeros, but the answer on the right hand side is a non-zero values, because this is an illogical expression. It shouldn't exist and it is invalid. So let's look at the condition here. So we need to check what would be the value of A such that this term is 0. A squared plus 4 is 0, and you simplified it. In this case, you need to consider the plus minus sign of the square root of 4. So you have A equivalent to plus minus of 2. And on the other side, we know that the A minus 2 should not be 0, because if A minus 2 is 0, then this would not be an illogical expression. So A minus 2 should not be 0, and A should not be 2. So now we have two sets of results here. Either A equivalent to plus minus 2 or A is not equal to 2. So let's use some quick check to determine which values or which range is the correct one. So if A is 2, let's say if A is 2, then you end up with 0, 0, and 4 minus 4 is 0, and 2 minus 2 is 0. So this is actually not an illogical expression. So apparently A equals to 2 is not our answer. And let's look at A equivalent to negative 2. So you have 0, 0, and 4 minus 4, and negative 2 minus 2. So you have a negative 4. So this is the typical illogical expressions, and hence we say that in order for the system has no solution, A equals to negative 2. Now let's look at another question, which is exactly one solutions. So from the inspection, you know that we have three unknowns, and in order to have one solution, you need three independent equations here. And since we only have three rows, we only have the first, second, and third rows here, we can't afford to have a row full of zeros or illogical expressions, because that would make our independent equations less than 3, and hence we couldn't get the exactly one solutions. So having said that, this A squared minus 4 can't be a 0, because if it is 0, which means that we only have two independent equations and we wouldn't have exactly one solutions here. So A squared minus 4 must not be 0, and A must not be plus minus 2. Well, on the other hand, the A minus 2 here should be considered this condition. And since the value of A minus 2 on the right hand side would not have any impact on the type of solutions, because it doesn't matter what will be the value of A here. Even if A is 2, you get a 0 here, so it will be corresponding to the value of the unknowns. X3 will be 0. We still have a solution here. So since the value of A minus 2 would not have any impact on the type of solution, hence we can say that to have one solution, A must not be plus or minus 2. So I can set it in another way. The values of A, it can be any other values as long as it is not 2 or negative 2. So you want to check, you want to confirm whether this answer is correct or not. What would you get if A is plus 2 or negative 2? So I will leave it for you to work out this. And the last question is about infinitely many solutions. So we know from the previous solutions you need 3 independent equations, non-zero rows, to have one solution. So what if you have less than that? If your independent equations is less than the 3 independent equations. So because you have 3 unknowns, let's say you have 2 or even 1 independent equations, which means that we lack of information and we have the free variables here. So the typical form of infinitely many solution is that you have a whole row equivalent to 0, such that you reduce the number of independent equations. So in this case, since the a is only a variable in the third row, so we can vary the values of a such that we get the whole zeros row here. Having said that, a squared minus 4, this term must be equal to 0 and a must be plus or minus 2. On the other side, a minus 2 must be 0 too, and in this case a is equivalent to 2. So we come to an argument again. We have two sets of data here. So which one is the correct one? Let's substitute let's substitute the values of a into this equation to see. So if a is 2, so apparently I would get a 0 0 0 0, the whole zeros row. So this is correct. And if a is negative 2, I will end up with 0 0 0 and negative 4. So this is not the typical form for the infinitely many solution. This is actually the illogical expression for no solution, and hence we reject this a equals to negative 2 conditions. Then we can say that to have infinitely many solutions, a must be 2, and this is how you decide whether the system will be inconsistent or consistent based on the values of the a here. Now I have two questions for you to try it out. The first, the second, and the third one. I want you to follow the steps that I have shown you above, and the answers have been given here, so try to check whether you get the correct answer or not. And I hope that this could help you in your preparation for your mid-semester exam. Thank you.